Hello everyone, I'm Sahil and we'll be talking about laws of chemical combinations today. So the combination of elements to form compounds is governed by the following five basic laws, starting with law of conservation of mass. It says that matter can neither be created nor be destroyed. This law was put forth by Anthony Lavoisier in 1789. He performed careful experimental studies for combustion reactions for reaching the above conclusion. This law formed the basis for several later developments in chemistry. In fact, this was the result of exact measurement of masses of reactants and products and carefully planned experiments performed by Lavoisier. We also refer to this law as the law of indestructibility of matter. The mass and energy are interconvertible, but the sum of the mass and energy during any physical reaction or chemical change remains constant. That is why now you understand why your teacher cuts your marks when you don't balance your equations. Moving on to the second law, that is law of definite proportions or law of constant composition. This law was given by a French chemist, Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. So, for example, Proust worked with two samples of cupric carbonate, one of which was the natural origin and the other one was the synthetic one. That means it was prepared in the laboratory. He found that the composition of elements present in it was same for both the samples as shown. Sorry, I haven't shown you the composition, but let me tell you the composition. For the natural sample, it was 51.35% of copper, 9.74% of oxygen, and 38.91% of carbon. And this was the exact same composition that was found in the synthetic sample that was made in the laboratory. And for another example, we can take the example of pure water from various sources or any other country. It will always be made up of only hydrogen and oxygen. These elements are always in the same fixed ratio of 1 is to 8 by mass. We can prepare a sample of carbon dioxide in the laboratory. Also, we can do this in various ways by heating the limestone, burning coal in air, the action of dilute hydrochloric acid on marble, heating sodium carbonate. However, we will always find that it contains the same element carbon and oxygen in the same fixed ratio of 3 to 8 by mass. The important thing over here is the ratio is of the mass, not the volume. Moving on. So we can say that irrespective of the source, a given compound always contains the same element in the same proportion. The validity of this law has been confirmed by various experiments. It is sometimes also referred to as law of definite composition. Okay. The third law, law of multiple proportions. This law, sorry, sorry, yeah. This law was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of a small whole number. For example, hydrogen combines with oxygen to form two compounds, namely water and hydrogen peroxide. Hydrogen peroxide is nothing but H2O2. Now, over here, the fixed masses of hydrogen, that is 2 grams, and the variable masses of oxygen, that is 16 grams and 32 grams. Here, the masses of oxygen, that is 16 and 32, which combine with a fixed mass of hydrogen, bear a simple ratio that is 16 is to 32, or we can say 1 is to 2. So this was the law of multiple proportions. Moving forward, we have the fourth law, that is Gay-Lussac's law of gaseous volumes. Or before that, let's talk about the law of reciprocal proportion. This law is not given in the NCERT books, but I find it essential or important for you to go through it. This law was put forward by Richter in 1792, and it says that the ratio of masses of two elements A and B which combine separately with a fixed mass of the third element C is either in the same or some multiple of the ratio of the masses in which A and B combine directly with each other. So it's a bit tricky one. We'll take an example for this. For example, the elements carbon and oxygen combine separately with the third element hydrogen to form methane and water. However, they combine directly with each other to form carbon dioxide. In methane, 12 parts by mass of carbon combined with 4 parts by mass of hydrogen. In water, 2 parts by mass of hydrogen combined with 16 parts of oxygen. So, it's, yeah, that's it for this one. So, we'll be moving to the next law, that is Gay-Lussac's law of gaseous volumes. This law was given by Gay-Lussac in 1808. It observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at same temperature and pressure, because the volume of any gas is a function of its temperature and pressure, and if we change that or if we vary it, the volume might not be same. Thus, for example, we can say that 100 ml of hydrogen combined with 50 ml of oxygen to give 100 ml of water vapor. Thus, the volume of hydrogen and oxygen which combined together, that is 100 ml and 50 ml, be a simple ratio, that is 2:1. Now, Gay-Lussac's discovery of integer ratio in volume relationship is actually the law of definite proportions by volume. The law of definite proportions stated earlier was with respect to mass. The Gay-Lussac's law was explained properly by the work of Avogadro in 1811. Or if you want, we can take another example, that is the example of hydrogen and chlorine. One volume of hydrogen and one volume of chlorine always combine to form two volumes of hydrochloric acid. The ratio between these volumes of the reactant and the products is always is this reaction in this reaction is simple, that is 1:1:2. Moving further, the Avogadro law. In 1811, Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules, or if we can say equal number of moles or equal number of amount. Avogadro made a distinction between atoms and molecules, which is quite understandable in the present times. If we consider again the reaction of hydrogen and oxygen to produce water, we see that two volumes of hydrogen combined with one volume of oxygen to give two volumes of water without leaving any unreacted oxygen. Yes. So however, Dalton and others believed at the time that atoms same kind cannot combine in molecules of the oxygen or hydrogen containing two atoms did not exist. Avogadro proposal was published in the French journal the Physique. In spite of being correct, it did not gain much support. Now, the last and the final theory that we'll be studying today is Dalton's atomic theory. Although the origin of idea that matter is composed of small individual particles called atomio, meaning individual, dated back to the time of Democritus, of Greek philosopher, it's again started emerging as a result of several experimental studies which led to the laws mentioned below. Sorry, mentioned in my previous slides. But in 1808, Dalton published a new system of chemical philosophy in which he proposed the following laws: that matter consists of individual particles called atoms. Second, all the atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. So what he was saying is that atom, if we take two atoms from the same element, they have an identical mass. But if we take two atoms from different elements, then they'll always differ in mass, not be of the same mass. Compounds are found when atoms of different elements combine in a fixed ratio. And the last one is chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. That is basically in accordance with the law of conservation of mass. He's saying that atoms are not created nor destroyed, they are just reorganized in a chemical reaction, and Dalton's theory could explain all the laws of chemical combination. That is why it gained so much of uh, that it became so popular in his time. This is it for this video. We'll meet in the next video and we'll be talking about atomic and molecular masses. Till then, you can refer to the NCERT books to cover up these topics, these law of chemical combinations, and any doubts can be put in the comments.